We now want to look at the situation that we had near the end of the last class, where we had delta S, A, and V naught and couldn't go anywhere with it. We did say at that point that if we take the two most fundamental equations and eliminate delta T from between the equations, we're going to have an equation in what? Delta S, V naught, VF, and A. Wait a minute, if we eliminate delta T, we don't have delta T here anymore, we have delta S, V naught, VF, and A. Right, and we can calculate VF because then we would have delta S here, we would have A, which is going to come from here, and we'd have V naught, so we'd be able to solve for VF. And we also note that if we eliminate VF, we obtain this equation. And let's review where these equations came from. This equation is nothing but common sense. What's A delta T? That's the product of acceleration and time interval. When we multiply acceleration by time interval, we get the change in velocity. That's what acceleration is all about. And what do we do with the change of velocity? We add it to the initial velocity to get the final. So this is what we get simply by considering what we can obtain from V naught, A, and delta T. One of the things we can obtain is VF by this relationship. If we consider V naught, VF, and delta T, we see that our displacement is going to be the average velocity, the average of V naught and VF, represented here, multiplied by the time interval. Displacement is average velocity times time interval. So these two are very, very fundamental, and we expect everybody to really understand what these equations mean at an intuitive level as well as algebraically. Now we reasoned this equation out from V naught, A, and delta T, I believe. It can be reasoned out from this. If we just follow our noses with V naught, A, and delta T, if we multiply it by delta T, we get VF, and then we put VF and V naught together and average them and multiply by delta T, and we end up with this expression for our delta S. That's essentially just putting these two equations together. And of course, this is what we get if we eliminate VF. If we plug this expression in for VF here, we're going to get this equation. Now, if we eliminate delta T from the two equations, this is what we end up with. Delta S equals VF squared minus V naught squared over 2A. That equation implies this standard form, and we have a fourth fundamental equation. So we have two really fundamental equations, another equation which is fundamental, and this is actually the least obvious of the fundamental equations. We have to go through these algebraic manipulations to get this equation. We can't just reason it out from the meanings of the symbols. So this one is a little bit less intuitive and has some interesting implications. But those are the four basic equations. Given these four equations and the values of any three variables, we can find an equation that gives us a value of the next variable. And then we can put those together into just about any equation and find the value of the last variable.